So next problem, problem number 2. In this case, we have the same 6 cases like you have seen in the previous problem. But the task now is very straightforward, is to calculate confidence interval for the correlations. I wrote that B and C only. Let me try and do the calculations only for one case, for case B. And remember that first you have to also to write down the correct correlation coefficient. So in this case, this is 0.88, we know, and this is minus 0.88. Okay, let me take the negative one. Okay, what we know is that first of all the correlation is minus 0.88, and we also know that the sample size is 100, right? So that's what we know. Now we also know that correlation doesn't follow any theoretical distribution. However, if we make a transformation, if we calculate another statistic which is called z prime, the z prime statistic is it follows the normal distribution, right? So the z prime, we know it can be calculated as follows. We take a half of the natural logarithm between 1 minus correlation divided to 1 plus correlation, which gives us the 0.5, or it should be other way around, of course. This is plus and this is minus, sorry for that. Yeah. So 0.51 plus minus 0.88, and then divided to 1 minus 0.88. Yeah. And then plus and minus is minus, minus and minus is plus, and then of course it should be logarithm here. Yeah. So that gives us 0.5 logarithm. Here we have 0.12, and here we have 1.88. And then I just take a normal calculator, and then I find out that the result will be minus 1.376 approximately, of course. Okay, so this is our statistic z prime for our sample, and now we can also calculate the standard deviation for this statistic. We know that the standard deviation for z prime it depends only on the sample size, right? We know it can be calculated using this formula found by Fisher, and then of course it's approximate solution, right? But we know that it's very well approximated by normal distribution if a number of values is more than 10, and we have 100 values. Should be good enough. So it's a square root of 97, and then again, if you take a calculator and do the calculations I did it before, you will find out that it will be approximately 0.102. Okay, and then let's say we calculate 95% confidence interval, which means that we need to take an interval of 1.96 of standard deviations. Yeah, this plus minus here. And then I just calculate this 1 times 96 standard deviations. It's 1 times 96 multiplied by 0.102. And again, you can do the calculations. You will find out it's approximately 0.2. So that's a nice number. Okay. First of all, we calculate 95% interval for z prime. So the z prime lower, the smallest possible, it will be simply we take a statistic minus 1.376 and subtract 196 times s, right, times standard deviation, and we know it's 0.2, so we can calculate it easily that it will be minus 1.576. So that's the upper boundary, the lower boundary, sorry, and then the upper boundary. I again do the same calculations, 376 plus 196 of standard error, standard deviation for z prime, and it will be minus 1.176. Okay, so this is the confidence interval for z prime, right, for the population. Now we know that we can always calculate, we can always get back from z prime to r to correlation if we use an inverse function, and I showed you several times how to find an inverse function, how to calculate it. So here I will just write it down. So the correlation is if you take e in the power of 2z prime, then minus 1 here, and then e in the power of 2z prime plus 1. Yeah? And then for 2, let me calculate this 2e in the power of 2z prime lower first. And again, I just take minus 1.576 times 2, and then use it as a power of exponential function, then I will find out that it will be 0.043, and then e in the power of 2 z prime upper boundary, I take minus 1.176, again multiply it to 2 and use it as a power of exponential function, it gives me 0.095. Yeah. Now I'm ready for calculation. So the rho, the correlation coefficient for the population, the lower boundary, it's simply 0.043 minus 1 divided to 0.043 plus 1, which is minus 0.957 here, 957 here, divided to 1043, yeah, 43. And again, if you do the calculations, you will find out it will be minus 0.918. Okay. And then the upper boundary, the same idea, but we use the upper boundary for the z prime. So it will be 0.095 minus 1 divided to 0.095 plus 1. And then this will be minus 0.915, I think, no, 905, I think, yeah, 905 divided to 1.095. Yeah. And then this will be approximately 0.826. So this is the confidence interval for the correlation, assuming that the sample, for the correlation of the population, assuming that the sample correlation is minus 0.88 and the sample size is 100. And then you can simply do the following, do the same calculations for this case. For case C, you remember that this is minus 0.41, this is plus 0.41. What you need to change is only calculate a new z prime, because z prime depends on the correlation coefficient while standard deviation will be the same. So this is pretty straightforward.